morning. Boker Tov. I'm visibly anxious. I'll use the Hebrew word, chared, because one could start this conference and think that technology will solve all of the problems in healthcare. And I'm here to tell you that technology has a great risk of making it much worse. In fact, right now, in most studies, including in Israel, 3 to 7% of all patients in hospitals are harmed. 3 to 7%. Touché. In the US, the studies have shown 50,000 people a year die in hospitals. 50,000. In the UK, it's 5,000. In Australia, it's 4,000. So we have to be a bit more sober about this phantasmagoric idea that technology will resolve all of our issues. I had to say that because I was just steaming over here, because it's not that technology can't help us. It's that we have to have a much more realistic sense of who are the people that are operating the technology. And with that, I'd like to go back to Nomi's comment about hospitals. Technology is really serving us this morning. I know why. It's a wrong-sided surgery here. This is why. Okay, so Nomi talked about the name Bet Cholim, but of course, Nomi, כמו שאת יודעת, בתלמוד זה בתי בריאות, זה לא בתי חולים. So we've lost, and the Romans copied the old Judaic text, and they called it houses of healing. We've lost that. We've lost the wellness component. We keep on focusing on the sickness. We keep on focusing on healthcare, which is a business, and not health, which is what patients want. And I really like Joseph's presentation to remind us that this is about the patients. It's not about the glitzy technology. It's easy to get seduced by that technology when all the evidence suggests that patients complain more and more of less contact, less trust, less emotional bonding. They're unhappy about that. Physicians say that technology causes a barrier between them and patients. When I deal with my residents in the operating room, when the machine goes blink, they don't touch the patient, even though they're right there. They start playing with the screen, even though the patient is 30 inches to 6 inches away. We have to remind them, remember, there's a patient here, not the machine. And a lot of times that leads to trouble because they treat the computer-generated images or data. And so this is a very, very difficult issue that we struggle with training. Again, the relationship between quality in the healthcare perspective and quality in design, and I'm going to rapidly go through that. We talked about harm. What is harm? How much harm there is? There's a lot of discussion and literature around this. The bottom line, though, is that healthcare still causes a huge amount of harm. And that needs to be the framing of any hospital design of the future. How much harm is still being caused? The harm, of course, causes pain and suffering. There's a huge amount of money. One could argue all that money is missing from the healthcare system. Some could say a third of what healthcare costs is waste money. Waste money because of inefficiencies, harm, and the relationships that are destroyed because of that. So, would you be happy if healthcare was 99.9% safe? Yes? No? Well, here's what it looks like. This is 99%. That would be 84 unsafe landings at Heathrow Airport every day. One major plane crash every 3 days. 16,000 lost mail items per hour. And 37,000 bank transaction hours per hour. That's 99.9% reliability. So again, 3 to 7% harm. This is reliability. So technology is wonderful, but we have to deal with the fact that we cannot deliver today highly effective, reliable care. Now, this is nothing new. We've known this for at least 40 years. The amazing thing is 40 years on, we're still harming just as many people percentage-wise, which is a quite disturbing thing. This is the work that we did several years ago. It's called a risk chart. This is very unsafe. This is very safe. I'm sure you've been reading about the Himalaya. Every week people are dying there now climbing mountains. Very, very dangerous. Civil aviation, about 10 to the minus 6. This is 6 sigma. This is 2 sigma. This is the range of human endeavor. Anesthesiology, the space that I live in, used to be over here. Here it is today. These are safe 18-year-old patients. It's about 10 to the minus 6, perhaps the safest endeavor in medicine. However, I do cardiac anesthesia, and we kill about 1 in 1,000 preventatively, and we harm about 1 in 50. Sobering, isn't it? This is so-called minor. What's the minor? eye lacerations, loss of hair, throat ache, canned pee, huge hematomas, delirium. Okay? 14% in anesthesia today. This is the largest study of its kind of minor, not the big stuff that we talk about, but the little things that the patients complain about. My point, of course, is to balance out and to realize that we need to understand what the epidemiology says about the harm today. So here's a question for you. Do you think, here in Rambam, or in any hospital that you work in, even the glorious Hadassah where I spend time, do you think there's a difference, and Shlomo isn't here, that was a bit pun, but do you think there's a difference if you have a major operation that's non-emergent, if it's done from Monday to Wednesday versus Thursday to Sunday, all else being equal? Of course. How big is the of course? Is it 5%? 10%? 30%? Where are the architects in the room? What do you think? I want to ask the architect, have you ever been in the hospital in the middle of the night? How about on the weekend? 99% of architects who build hospitals are almost never there in the middle of the night or the weekend. They think that the hospital is like a Monday to Friday kind of thing. The evidence shows that on weekends there's 20% more mortality, 20% more. How do we accommodate the design to understand that? This is the largest study of its kind, 36% difference if you have the operation from Thursday to Sunday. That's it, which is really startling. Because guess who's at the hospital on Sunday? Is it the A team, the B team, or the C team? The physicians, the nurses, the administrators. Nobody's there on the weekend. It's more like that's why we call it the graveyard shift, literally. It's very, very quiet, hospitals on the weekend. So I want you now, and I hope this works, no sound. I want you to count the number of passages of the white team only. The basketball passes of the white team. If you've seen this, please don't say anything. Just keep on counting the basketball passes of the white team. Okay, so how many passes did you see? Who saw 5 passes? 10 passes? Who saw the gorilla? Are we sure everybody? I don't know, about 50% aren't raising their hands. The truth is about 50% miss this. This is human factors. And one of the world leaders on this is not here. He's from the Technion, Danny Goffer, who's a friend. And he should have been here for next time, but he's at a different conference, the Minerva conference. But Danny, for 40 years, has talked about the human factors of physical design. The unintended consequences is that I told you to focus on one thing, so you're distracted. Your attention span, your keshev, is the most valuable thing that you can have or lose. And that's what this is about. Now, of the architects in the room, how many of you actually deploy human factors experts when you design hospitals? I don't think so. In fact, not one hand has gone up. Because Danny Goffer said he's never been hired to design a hospital. He designs lots of factories, but never hospitals, which is interesting. But these people are experts, that's what Danny does, in focusing on what we call these mental models. So Peter Senge says that if you want to understand people, you can't just give them the facts. You have to understand what is the observed experiences, Jos, that leads them to come to decisions. You don't change people with facts. Although I was taught at Hadassah that facts will change the world. Sadly, it doesn't work that way. It's the stories around the facts that change. And so what is the story around this? What is the qualitative sense? What is the understanding of the flow and the process? So we've done a lot of work on creating risk management models in which we work with architects and designers to think, how is this hospital going to cause harm or mitigate harm? For example, I always ask architects if they're allowed to see the real adverse events in the hospital. And they always say to me, no, it's secretive. They're not allowed to see it. So they're designing this $500 million hospital, but they can't actually see the harm that this hospital causes. Instead, they go around the world to the literature, as opposed to actually saying, in this hospital, in this unit, how have we caused harm, falls, infections, or things of that nature? Probably the most important book in this field is Donald Norman's book, The Design of Everyday Things. Imagine if you had coffee this morning, what would happen if you poured it? This is setting clinicians up for failure. This is the systems that we cause. So we saw these beautiful pictures, and we're going to talk about some of the human factors in just a moment now. So what is human factors? Of course, there's the hard stuff, machines, technology, but we've spent a lot of time on this, the soft stuff, teams, collaboration, sharing, learning, the non-technical skills, which right now is still not part of the curriculum in the Technion, I don't think. And it's not part of the curriculum in Hadassah either. And it wasn't part of the curriculum where I am right now. We're not teaching non-technical skills by and large. We assume by osmosis that we'll pick it up like ethics. But sadly, we don't really teach how to work in teams. The assumption is it comes natural. And the reality is it doesn't always work very well, as we know so well. So we have quite a bit of disruptive individuals. So the work really suggests that in order to design safe operating rooms, you have to focus on these things. And notice that technology is there, but it's one small element of the many other that integrate and influence that process. So I want to quickly show you an example. We've been focusing on a topic that's hot around the world called alarm fatigue. And the first thing that clinicians do when the alarm goes off is do what? Do you know? Silence it. All right. So now there's been at least 800 cases in which patients who needed the alarm, but it was false positive, and they turned the alarm off, only to find out the patient was dead when they got back to the bed. Now, the response of the companies is to design more and more alarms that you can't turn off, right? Now, because most of these ORs have at least between 40 and 60 different types of alarms, which don't talk to each other, they cause cacophony. And they cause acoustical nightmares. And they raise the blood pressure of the patients, the staff, they reduce sleep, they distract attention. They're a serious, serious problem. So acoustics of hospitals is being driven by technology because we're not thinking about the human factors of it. And if you think what the problem is that, imagine what you're going to do this afternoon when you walk by a car, that alarm goes off. What will you do? Ignore it. And that's exactly what's happened. We ignore the alarms because we abuse the environment around the clinicians. Again, human factors, design companies, a lot of complex stuff, and we've written several papers on this, which I'm glad to share afterwards. Because of time, I'm going to move on. This is the work that we focused on, which is how do we take the operating room as a laboratory of performance and break it down to the people, the processes, the culture, the flow, to understand why do we have lag times and delays? Why do we have inefficiencies? Why is there, in Israel, 2 to 10% infections around the operating room, which is an international level? 2 to 10%. 1 sigma. Yes. These are the real numbers. So as we keep on talking about these gorgeous technologies, we need to look at the epidemiology of infections. And do you know what? One of the key reasons why the ORs are still so infected? Well, I'm going to show you this study. So this was published last year, and I'm sorry the images are coming. This is from the Netherlands, and we had covert observers watching nurses, surgeons, and anesthesiologists wash their hands as they came into the operating room, not the surgical prep. This has never been done before scientifically. How often do you think that surgeons, nurses, and anesthesiologists wash their hands when they come into the operating room? Always? 50? 30? Anybody want to give me 10? When you present to clinicians, they say, we don't. In fact, they don't even jump up and down. They just say, we don't. We call that normalized deviance. Sorry? It's in Norway. It's a serious problem because last year, colleagues of mine at Dartmouth showed that when you swab the walls in the OR and the IV poles and the gorgeous keyboards on the devices, they're teeming with bugs. Because the process of cleaning the OR now looks like a car wash. Have you ever seen it? It's a 15-minute rub down. That's what it looks like because it's productivity. We got to get the cases moving along. And the suggestions now, it has to look more like a microprocessing. Have you ever seen the way they make microprocessors with all these sterile... Maybe we should clean ORs in a similar way because the walls are teeming with VRE, MRSA, and many other problems. So again, this is not radical because we've been able to demonstrate that lack of hand washing leads to bugs in the OR, leads to infections in patients down the road. The same serotypes are in the swabs. So here's my question to you. You work at John F. K. Airport and you have a problem. The men are not tidy. When they pee all over the wall. And you're in charge of quality and you're like, what am I going to do here to reduce the cost? So you have 4 options. Option 1, you hire somebody to reprimand the user and say, stop peeing outside the urinal. Option 2, you hire a statistician from the Technion who plots out a gorgeous PhD curve and says, look, here's your variation in p-value. Option 3, you buy bigger urinals. And option 4, you put a fly on the porcelain. What do you think works the best? That's right. This is the answer. And if you go to Schiphol Airport, you'll see that all the urinals have a little fly. And because boys like toys and aiming, they shoot well. And the cost went down by 2/3. This is not technology. This is simple sociology. Now, I want you to think about how this relates to how technology shapes and changes behavior. If you want clinicians to change their behavior in the hospital, what is the fly in the urinal? What's the equivalent? If it's rapid response teams, or timeouts before surgery, or giving antibiotics on time, or talking nicely to the nurse, or whatever. The reason why physicians aren't compliant, because we haven't identified the fly in the urinal. It's about attention. It's about engagement. And we've known this for at least 150 years. In fact, Semmelweis, as you probably know, the first person to identify that when physicians touch patients, the patients die. Yes? Because if you delivered your baby outside the hospital, you lived. If you delivered it in the hospital, you died. And they put him into an insane asylum because they said he was nuts. It's a true story, 160 years ago. So this is work on single patient rooms. It was discussed earlier, and Arthur, I guess you're going to talk about this later. But here's the evidence showing that hand washing of doctors increases by 74% when you move from 6-patient Florence Nightingale wards to semi-private or private rooms. Just that. So the technology, the physical design, shapes the behavior. The unintended or intended consequences of the technology is what we should be talking about. Not just the glorious micro stuff, but how it shapes the performance and behavior of the teams. Here's another example. This is medication error rates by nurses in ICUs. And all you do is change the lighting from 480 lux just to 1500, and the medication errors go down from 4% to 2.2%. That's it. Just the lighting. Now, Danny Gopher did this 25 years ago in industry here, showing that more lighting leads to left fingers getting sawed off near Soltam. That's it. So they improved the lighting, and the injuries dropped by 75%. Just the lighting. Nothing else. No new technologies. Just attention. Attention to detail about how we are focused around what's going on. Nurse, go on the internet, go to surgery.com, scroll down and click, are you totally lost? And so this is one way that we're looking at the technology that will solve our problems, and we heard an allusion to that earlier. Now, I want to very quickly talk about innovations, because hospital design is a problematic process because, as Jos said, by the time we bring technology in, most of the decisions have been made. And so it's very difficult to change the operative settings unless we bring it in at day one. And so this is really a fascinating thing about innovation. It's not about healthcare technology. It's about how do we innovate in a very complex, very old way of learning and listening and learning from science. Just to give you a sense, I once gave a keynote, and I said that the rate in which architecture learns from new innovation is equivalent to the way it was 100 years ago in medicine. I know that was a startling statement. Right now, there are only 4 or 5 programs in the entire world that certify healthcare architects. Furthermore, how many peer-reviewed architecture journals are there in the world? Does anybody know? Maybe 1 or 2, which was how it was in medicine about 100 years ago. So the training is not specialized. The journals don't science that way, and so they have to learn one at a time. And one of the pleas, I hope, of this conference is to develop more rigorous research around evidence-based design. So I want to quickly talk about hybrid operating rooms, and there's 2 papers we just wrote on this, which is these new concepts of these rooms that combine surgery, radiology, and main OR, flexibility. All these people are fighting for space like angry birds. And guess what? These people don't particularly like each other. They're very, very different. Cardiologists or surgeons are about as far as possible as you can get on the spectrum. They're almost as psychiatrists and pediatricians. They're very, very different. But we just talk about their needs, but we don't talk about their social needs. So in the project that I'm involved in Florida recently, the surgeons really wanted to have full transparency between the cath lab and the OR. So they build them next to each other with windows into the OR, into the cath lab. The surgeons loved it. Do you know what the cardiologists did the first thing they moved in? They tinted the glass so they couldn't see inside. It's an amazing example of mental models that nobody even asked them. They don't want to be transparent. They're not interested in that. But if somebody would have asked them, we would have known that they're not comfortable yet in full transparency. Now, cardiac surgeons have been under the microscope for 30 years, so they're comfortable for being examined. Cardiologists are less so. So we have to deal with the sociology of the space. This is the platform that we play with. You know, we've talked about technology which is organ-based, versus technology, versus device-based. But of course, we have to move towards the service-based, the savings, the co-locations. You've heard a little bit about that earlier, the sharing of space. And so here it looks, this is the flexible technologies, the flexible spaces. Here are the flexible services. So there's a movement here between OR, imaging, and combined. And we haven't really talked about the psychology of the space. We're talking about the technology. And the challenge is the psychology will come in 20 years, and by then we're poorly designing these spaces. Here's another way of looking at it. We look at these flexible dimensions between a clean space and a non-clean space. And how do you define what's clean and what's not clean? For example, radiologists and cardiologists do procedures usually with their tie on and with gloves. They don't really wash their hands either. It's just a different mental model. In surgery, we would never accept how they prepare for their procedures. So if we're going to move together, we have to shape how they prepare for the OR. Again, this is a social science dilemma. How many of you architects employ social scientists when you build hospitals? No hands. Here's a big challenge for the Technion. Social scientists is the future of healthcare design. That could be the subtitle of my conversation today. Here's another example in which we looked at where do you put the soiled corridor? Do you put it in between, which causes more traffic? And we know that mediastinal infection is directly related to how many people come through the OR. We put monitors on the door, more people walk in, more infections. Very difficult to cure. However, if you put the corridor over here, or you put the thoracic corridor at the end, nobody walks through it. So this, again, you shape the behavior through the physical design if you know the literature around the co-location and movement. Here's another example in which we look about, where is charting going to happen, clean flow, soil flow. Again, these are things that architects know intuitively, but clinicians don't always think about it that way. And so this is the bridge that's needed. How do we build the consensus when it's so radically different? Everybody says, I want more cath labs, I want more ORs, I want more office space. And then the austerity measures say we're going to cut how it's called value engineering. We're going to cut 30% across the board, which of course loses the value of the uniqueness of each of these specialties and definitely buys resistance, which lasts for years afterwards. So several hospitals are in industrial action because the clinicians were not told the truth. They said, oh, in the consultation, the architect says, oh, we'll give you this, we'll give you that, and then later on, we changed everything, but we didn't actually tell the clinicians, and so they're not particularly happy about that. So the culture shock. Here's an interesting study. They asked clinicians if they could actually measure the distance from the clinician here to the wall. Seems straightforward, right? And so here's what they asked them, 600 square feet OR, net versus gross. Do clinicians understand a simple metric of space? What do the architects think? Yes? Well, we shall see. So here's what they did in this study. They compared team meetings, interviews, computer models, simulations, and site visits to how easy was it to explain what 600 square feet means for the wall versus the clinician. And as you can see, the thing that worked the best was the site visits. Unless they actually saw it and kicked the tires, they didn't believe the pictures, and frankly, they can't read the pictures, most of them. So stop showing them the pictures, okay? Clinicians don't know how to read 3D pictures because they're not taught to read 3D pictures. And unless we help them with a small exercise, they're going to continue to say, yes, yes, of course, and then they sign off, and 2 years later they go, did I sign off on that? And they go, yes, here's your signature. They go, oh, okay. Because they're not part of that trained model. Again, this is the mental models. So I want to wrap up here. These are some of the tools that we use to facilitate understanding. The architects know this quite well, but of course, I think this is the most powerful one. These are mock-ups. And of course, the best part is the site visits. You actually have them come in. What does it actually look like? So in the US, the first place in the world, I think, and what a great thing to do in the Technion, they have a whole hangar that was converted into a modular hospital where hospital teams can come and move the new hospital around. So the OR, the ICU, the ED, and it's a lovely research space. It's run by Kaiser, and it's a wonderful space for thinking about the design of the future because you can actually see and touch and convince people through real examples. And here you can see other examples. So I want to end with the most important part, if it's not clear, which is the culture. So NASA is famous for many things, but one of them for having a quite toxic culture. And that was very clear in multiple studies in which they kept on normalizing deviance. They kept on breaking the rules, which is why they blew up two big satellites. And what's interesting about that is that NASA is held up for its safety, but also for the fact that it has a very hard time dealing with its norms. And NASA norms are nothing compared to medical norms. And anybody who's a clinician in this room knows what I'm talking about. The norms in medicine are so deep-seated They're so deeply socialized that it's very difficult to change them. So we did a study in 3 separate ORs in the US, 72 response rate, and we asked these teams several things, but I just pulled out 3 things. One, did they feel that the outcomes were safe in their operating rooms? And 45% said no, which is really interesting. 33% that the errors keep on happening, and 47% felt that administration doesn't care. Now, these are 3 of the best hospitals in the US: Boston Children, University of Chicago, and University of Miami Children's. So this is the culture again. But if we don't ask them these things, we're not going to get the answers. And of course, this is Ron Westrom's. Do we have a pathological culture that supports engagement and discussion? Can you actually tell a nurse to a physician, you need to wash your hands? Can a clinician tell an administrator, your budget cutting is going to kill patients and not lose their job? Or is it such that we're actually building in what's called the high reliability culture, where people can talk safely about this innovation and design in a way that allows what we call the big team. This is called team steps, the trust, the shared mental models, and the communication. This needs to be part of medical training from day one. We're not teaching this right now, either in nursing or in medicine. And so if we want to build these physical spaces that co-locate, we have to start developing the people so that they learn to respect each other and trust each other, because otherwise we're not going to get high reliability. We're going to continue to get 3 to 7% preventable harm in Israel, because those are the numbers, 3 to 7%. These are very, very high numbers. And so they're quite low reliability compared to the science. I can't end without saying something about sustainability. Hospitals are some of the most expensive carbon footprints in the world. So we talk about planes, but we need to talk about hospitals and sustainability, because of the air conditioning, because of humidity things, and because the way we've designed them, they're hugely wasteful. In the OR, we waste at least 25% because we don't reuse our materials. The cath lab, it's at least that. So that needs to be part of the discussion going forward with sustainability. Again, that was discussed earlier. This is, last 2 slides, this is the evidence-based design. One very quick example: single patient rooms, access to daylight, nature, carpeting. There's a growing evidence, and this is the future, really, of making architecture more accountable to the data. And I say that advisedly because I work a lot with architecture firms. We need to help architects and engineers understand the methodologies that they can use to develop better arguments to convince clinicians that they need to do these changes, and they're able to push back against administration who says, we can't do that, there's no evidence, it doesn't actually make a difference. And so these are the fields that we in the Center for Health Design in California have been focusing on: nurse station typology, workforce efficiency, the single or other patient room, workforce retention, which we know is a problem, infections, falls, errors, and workforce safety. A lot of this you can find in these 2 papers that came out this year. And of course, finally, we can't not talk about the money, because money is being cut right and left. Not enough is being spent on safety, so please be careful. Thank you.